Hi everyone, welcome to the study of non-homogeneous O.D.E. We are mostly interested on how to solve the particular part using the method of variation of perimeter. Now, this equation which we are given y double prime plus y is equal to sine of x, we are going to first of all start with the reduced form, which is y double prime plus y, which is equal to 0. Here we are going to let y to be equal to exponential mx. We differentiate y once to get y prime, which is equal to m exponential mx, and y double prime, which is equal to m squared exponential mx. Exponential mx. Then, from there now, we substitute where you have y double prime, you substitute it with m squared exponential mx plus exponential mx, which is equal to 0. We can factor exponential mx so that we'll be left with the m squared plus 1. Note that in this case, exponential mx cannot be equal to 0, meaning that m squared plus 1, it is the one which is equal to 0. So here, m squared is equal to -1, taking 1 the other side. Then we take square root both sides so that we'll be left with m, which is equal to plus or minus I. When you take square root of a negative number, you get a complex number. So then we write our y complementary or our auxiliary equation, which is equal to c1 sine of x plus c2 cos of x. Then, by method of variation of perimeter, we are going to solve now this other part here by we are going to let our C1 be equal to U1x, which is equal to U1. Then, we let our U2 to be equal to U2x, which is equal to U2. Meaning that now our U1 prime Y1 plus our U2 prime y2, this is equal to 0, and our y1 prime multiplying plus u1 prime y2 prime is equal to rx. In the case we are dealing with, our rx is equal to sine of x, and our y1 is equal to sine of x, and our y2 is equal to cos of x. So we are going to substitute them here and differentiate. So we shall have u1 prime sine of x plus u2 prime cos of x, which is equal to 0. Differentiating, we are going to get u1 prime cos of x minus u2 prime. We differentiate cos of x to give us sine of x, which is equal to sine x. Now, from linear algebra, this can be written as sine of x cos of x. We can write it in matrix form: cos of x negative sine of x. u1 prime, u2 prime, we put the matrix into bracket, which is equal to 0 sine of x. That way. So the next step, we are going to determine what is called Wronskian of y1, y2, which is given by the determinant of this matrix: sine of x, cos of x minus sine of x. So you obtain the determinant of this, which will be sine multiplied by sine. This will give you negative sine squared of x minus, we subtract the product of the other diagonal, mean diagonal minus the product of the mean diagonal minus product of the other diagonal gives you the determinant cos squared of x. From here, of course, you can factor negative outside so that you'll be left with the sine squared of x plus cos squared of x. This is equivalent to -1. Sine squared of x plus cos squared of x is equal to 1. Multiplied by negative, it will give you negative. Then you obtain u1 prime, which is given by 1 over the Wronskian, y1, y2, modulus of 0, sine of x, cos of x, negative sine of x. We get that determinant, which is equal to, this is 0. We shall have -1 into bracket. 0 multiplied by this will give you 0 minus sine x cos x when we multiply. So u1 prime is equal to sine of x cos of x. Now to get u, we integrate both signs so that now you have u of 1 is equal to integral of sine of x cos of x dx. Now we can integrate this part by what is called u substitution. So we let our u to be equal to sine of x, so that our du will be equal to cos of x dx. So you can substitute here so that you have integral of u d of u, substituting cos of x dx with du and sine of x with u. So when we integrate u with respect to u, the result is u squared over 2. Then from there now, u1 is equal to half sine squared of x. Then from there now, we determine u2 as follows. So u2 will be given by 1 divided by Wronskian, sine of x, cos of x, 0 cos of x, which is equal to -1 into bracket. This is sine squared x that way. So u2 prime is equal to negative sine of x squared. So to get u2, we are going to integrate sine of x squared, that is negative outside, which can be written as -1 integral of half into bracket 1 minus cos of 2x. Or now to integrate trigonometric function of even, you can check in my YouTube channel so that you may find how we come up with this result. So u2 is equal to negative into bracket half x, then minus 1 over 4 sine of 2x, which can be written as negative half x plus 1 over 4 sine of 2x. Now our yp will be given by u1 y1 plus u2 y2, which is equal to our u1 we have found it to be sine of x. So and our u1 we have found it to be half sine squared of x. So this is equal to half sine squared of x multiplied by sine of x plus cos of x multiplied by what we have here, negative half x plus 1 over 4 sine of 2x. So finally, our solution of the given O.D.E, our O.D.E is of the form y double prime plus y is equal to sine of x. So our complete solution, y will be given by y complementary plus y particular, which is equal to C1 sine of x plus C2 cos of x, then plus half sine of x cubic plus cos of x sine of 2x divided by 4 minus cos of minus x cos of x divided by 2. So that is our complete solution of the given O.D.E. Thanks so much for taking your time to study with me. For more such questions, tune on to my YouTube channel so that we may continue learning together. Bye-bye. Thanks so much. Kindly subscribe to the channel so that you may continue learning mathematics with me.